Okay, let's start the class. So the first question, there is a one ketone is there, and there is a you can say this is alpha position, beta position, gamma position, and delta positions. So delta position, there is a beer is attached, and if I look into the reagent, so this above reagent is basically sodium ethoxide, and this is basically DMSO. DMSO is basically dimethyl sulfoxide. Dimethyl sulfoxide is basically S double bond O CH3. Do you know dimethyl sulfoxide is a solvent? So solvent, it just accelerate the reactions. It has no as such much roles in these reactions, but yes, this is the base which is the major role in this case. So if I see in this case, there is a alpha position, there is a hydrogen. One is a phenyl attached, another is a hydrogen is also there. And if I see, there is if sodium ethoxide, that base, and this base will take up H+, and it will form a carbanion. So if it is form a carbanion, so it will this kind of product it will form. CH3, C double bond O, C negative, C6H5, a Br. Now see in this case what it will happen, and there is a in this case, this is the carbanion, and there is a next C double bond O group is there. So what it will form? It will form a enolate. CH3 CO minus double bond, and this will form a C6H5. And this minus will go and it will attack here, and Br will be out. And in this case, it will form this kind of product. There is a O minus O, there is a CH3 C6H5. So this type of product it will form. So now see, so finally this product it will form. Okay, your question will be, why it is from 6-membered ring? If it is any chance, we know Br is a living group, very good living group, and I can see there is a negative charge on oxygen. So what it will do, it will directly attack with Br center, and bromine it will released, and after release of bromine it will form a 6-membered ring. If any systems in 6-membered ring, so that is very good systems. So that's why in this case, in this kind of product it will form. So if I see the answer, so in this case answer will be second answer, so which is exactly same. Okay, so coming to the next question, is a next question. If I treat with X, then it will form a that diketone, and then Y it will form. And after that Y, if I reactions with KOH, and it will form a this type of complex. So now see, you can assume this diketone, diketone is only formed if I directly this double bond if I break it, and if it is in form of oxygens, so it is form of diketones. So this is only possible if I use O3, if I do ozonolysis O3, and this is reductive ozonolysis because if ZnH2 is there. So this reductive ozonolysis if I give, so this kind of one, this is basically if I marked it a diketone, it will form, and side there is a beside this type of aldehyde it will form. And if I reactions with KOH, aldehyde and ketone, if I react with KOH and there is nothing is mentioned that 50% or something, if it is in 50% something, then in this case there is a possibility to form a, okay, just a minute, okay, I got it, the X. Let's see the second options. Is there any option is there? Okay, so I just need to mark that X and Y. X is basically O3 and ZnH2. So this is the second options. And your question will be, what is happened this ones? See, this KOH and this aldehyde, so this will give a Canniger reactions. Do you know both aldehyde, there is a one part of aldehyde after giving the KOH, it will form a one part of aldehyde, it will form a CH2OH, and another part of it will form a acid form, salt, potassium salt of acid. So this is basically exactly same like this. So last step happened in the Canniger reactions. So this is, and I just need to mark, there is a X, what it is X, and Y. So X is a O3 and ZnH2, and Y is a, this is glyoxal. This is called a glyoxal. This is called a glyoxal. This is called a glyoxals. Okay. Coming to the next questions. So there is a CH4, and there is a fourth option is there, and if I treat among these four reagents, and finally it will form. So this is basically what it is. This final product will be 1, 2, 3. So 2-methyl propionic acid it will form. Now see, there is a reactant, there is a one carbon is there. So if I give something, so it will form a total how many carbon? 1, 2, 3 carbon. Total 4 carbon it will form. So now see, if I give Br2H nu, that is the first reagents. So if I give Br2H nu in CH4, it is just a alkane, halogenations of alkane, it will form a just a CH3Br. This is called a methyl bromide. And if I at the next step, there is a ethyl magnesium chloride. That is a delta minus, and if I give the delta minus, it will react and it will release this one. So it will form a CH3 CH2, 2 carbon and 1 more carbon. So it will form a, that ethyl group is gone, so that means CH3 and there is a ethyl group. So okay, So this will form a, okay, I am giving you this one, so I am rewriting this ones. Okay, okay, so this one it will form CH3 CH, and this is a, okay, I'm rewriting. I am rewriting this one. So first if I give this one, so this is a, this is CH4. If I treat with Br2H nu, so it will form a CH3Br, and in that CH3Br if I give CH3, ethyl magnesium chloride, ethyl magnesium chloride, so this is magnesium is a delta plus and this is a delta minus. So this delta minus, it will act as a nucleophilic center, so it will directly attract and it will release this one. So what it will happen in this case, there is a CH3 and that CH3 and that CH3, there is a CH3, and this one it will form a CH3 CH2, and if I give a Br2H nu, just ethyl will attach in the this one. So this is a N-propyl chloride, N-propane. Now see, in this case if I react with Br2H nu, so Br2H nu, what it will do, this will also react and it will act, it will react in a halogenations of alkane, jaise brominations of alkane. So this reaction is basically radical mechanism. So in this case, so it will form a CH3CH radical CH3. So this is Br2NH. Now in this case, formic acids. So in this case, formic acid, if I give radicals and formic acids, there is not such any kind of reactions will be there. So if I give the next reactions, there is a CH4, and if you react with Cl2H nu, as it is halogenation, so this one it will form, and then after that there is a ethyl magnesium chloride. So in that ethyl magnesium chloride, this minus will go and react with this one, so it will form a this one. It's not an issue. Next is Br2H nu. So that middle, okay, where radical mechanism and bromine will be attached. And if in that case bromine and formic acid, there is no such reactions, but in this case bromine. Now see, in this case there is a last step, that is a KCN is attached. KCN, there is a CN minus will directly react with this center and bromine will attach out, so it will form a CnCH3. So it will form a, if I add H3O plus medium, so it will give a CH3CH3OOH. So now if you see the product, this one and this one, this is exactly same, but there is no other reactions will give these ones. So answer will be 2. Answer will be second. So second also you have to do. And third, if you give, so NaNH2 base is something there, nothing will be there, and this is CH3Mg, where this is also will not give any kind of reaction. So in this case, so answer will be these ones. Chalo. Next, go to the next questions. Yeah. So in this case, there is a among the following the total number of compounds which give the positive iodoform test. Positive iodoform test, you know already. Positive iodoform test, there is a, if it is in two systems, if it is in CH3CO this group, and if it is CH3CHOH this group, and if I react with I2 NaOH, so it will give a iodoform. It will give iodoform. So this is the iodoform. So if I see these systems, so it will give a iodoform test. Let's see one by one. That the first compound, this is the secondary alcohol. So secondary alcohol, this system is there, so that means it will give a iodoform test. Is there, this one is the CH3CHOH system? No, it will not give iodoform test. This ethanol, this is also will give a iodoform test. So if I write this one CH3CH, no, this is also will not give iodoform reactions. Yeah, if I see this ones, yes, this is this cases there is a CH3CO group is there, so iodoform test. In this case also CH3CO group is there, iodoform test. CH3CHOH is there, so iodoform test. And yes, this is the correct answer. So in this case, okay, now you will be asking that CH3CO group is there. In this case, there is a CH3CO group is there. So you will be asking, sir, this one also will give a iodoform test? No, it is not possible. Can you see this one CH3CO group, which is not a purely CH3CO group, it is always participate in conjugations, so it will not give the resonance, it will not give the iodoform. Similarly, this also, so this is also will not give a resonance, will not give that, you know, that oxygen OH minus will not give iodoform test. And also in this cases CH3CO OH, this is the acetic acids. In this case, if I add I2 NaOH, you know, basic medium, OH minus if I give, so it will take up H plus. It will always take up H plus. It will never ever attack here. So that means it will never ever attack here. So that means it will not give a iodoform test. So how many products in this cases? 1, 2, 3, 4 product answers. Okay, let's go to the next question. Yes, this is very important questions. Now see, in this case there is a and A it will form a CHO, and beside it will form a this type of ketone it will form. Now see, so this is the basically B and this is C. Now see, if I do this one B with NaOH, and that is mentioned it is in 50%, so 50% means this is a Cannizzaro reactions. So Cannizzaro reaction means one part it will be alcohol, another part it will be C double bond O minus. Now see, and this is basically this O will directly attack and it will come, it will out. So it will form this type of system. So this is basically, yeah, this is your D and C. And now see, there is a C. I want to see this C. This C is basically acetone. I am writing here. And this C, if you add KCN, KCN and H3O plus and the acidic medium, Cn minus just it will attack and it will form a CH3C CH3 CnOH. And if that is a H plus medium, H3O plus, so it will form a CH3 OH C double OH. So yeah, so this is the correct answer. So answer will be C. But see, your question will be if it is in A, why it is not A? It is not, because if I do ozonolysis, that first step it will give a 3 product. One is acetone, another is acetaldehyde, and there is a 1,2-diol benzyl 1,2 phenyl, there is a 1,2 position 2 aldehyde group. So that is 14A is not possible. If you see B is also not possible, because there is a aldehyde it will form after doing ozonolysis, and there is a NaOH and there is extra more carbon will be there. So this is also not possible, and this is also not possible because if I do, there is a something different product. So answer will be C. And now let's see there is a one more question on this structures of B. What is the structures of B? B will be this one. So now see match, answer will be B. I hope you understood this ones. Chalo, next go to the next question. Yeah, so this is basically, this is alpha halo ester is there. And now see, there is a, in this case the reagent is PPH3. PPH3 is the triphenyl phosphine, and ethoxide, this is the base, and aldehyde is group is there. So one by one half, if I add the reagents, let's see what product it will form. BR PPH3 is the triphenyl phosphine. So PPH3 will directly go, so it will form PPH3 plus O18. Next, if I add ethoxide, C2H5O minus, so it will, this is the base and it will take up H plus from here. So it will form a PPH3 plus, this is negative, this is so OET. And now see, this minus will go, this is minus will go. So this will form a PPH3 plus, and this will form a O minus, this is form a OET. Now see, now in this case, if I do, this will come back and this will form a CH3CH, this will form this one, C double bond O, OET, this will form a PPH3 plus, and attached to it CO minus, and this is CH3. And now what it will form, now see, this one is the PPH3 and there is a next O minus, so it will form a it will cyclize, like negative positivity is attached and kind of cyclization it will happen. CH3CO PPH3, there is a C double bond O, OET. Now see CH3CH, and okay, in this case this kind of double bond it will form and it will be out PPH3 double bond O systems. So what it will form, CH double bond CH COOET. So this is the correct answer. Is there any compound is there like that? Okay, why this is called a betaine structures. You know, this cyclic ring is called a betaine intermediate, which is formed in the Wittig reactions. Betaine intermediate. You know, in this case PPH3 is basically PPH3 and O is this is the very, you know, strong bond. It has a high bond energy, strong bond. It has high bond energy. So because of the driving force of this high bond energy, that PPH3O will be out and it will form this kind of systems. It will form this kind of system. So let's see the answer. So there is A is the correct answer. Let's see the next questions. There is a CH3CO, this one, and if I add H plus, so it will give a C double bond OH plus and CH2H. So what it will form, this is this kind of CH3C OH double bond CH2, ये जाएगा, उसके बाद CH3C double bond CH3, it will be out. So it will form a CH3C double bond O CH2 C double bond O, C double bond O CH2 if I add, so CO minus, and there is a CH3. Now if I do again like this, so this is kind of aldol condensation will be there. So again this H plus will be protonated, that oxygen will be protonated, and it will form a CH2 CO minus CH3. Now in this case there is a CH3 which will be CH2H. It will come, it will go, so it will form a CH2 double bond COH, CO minus CH3. Now again if I do aldehyde, because repeatedly I need to do, so that means if I do aldehyde, so this minus will come, so it will form a C double bond O CH2 C. There is a O minus, and there is a CH3, and it will be as it is like this. So this is the repeated is over. Okay, if I do B, so B cases will be this side double bond, there is a water will be out, so that means, so this is H, after protonated this water will be out, and B it will form this one. So answer this one will be B, this one, CH double bond CH3. And now see last cases there is a NH3. Last cases there is a NH3 if I add, just a minute, repeat it. So this will be OH, and in this case this will be double bond, let me correct it, just a minute. This will be double bond, 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 because of water, minus water is out, so this will be water. Now see, in this case NH3 is attached, so it will give a H plus, and it will form a, so if I add this one, so it will form a CH2 C double bond O CH, and minus it will take up, and then it will form a CH minus, so it will form a C CH3, and NH3 after H plus it will form a NH2, and in this case this will also get protonated, also it will get protonated, so it will be this NH2 will directly attach this one, and it will be out, and this is also will be protonated, so that means CH3 C double bond O CH2, So this will form a CH3 CH3 NH CH3 CH3, this one. So is there any answer is there like this? Yes, I can see this is the second answer, is the correct answer. Okay, this is very important question. This kind of questions will come in your JEE Advanced. This kind of mechanism is there. Okay, let's go to the next questions. Yes, this is also very good questions for JEE Advanced. So if I do these reactions, there is a Cl CH2 CHO, and I can see this is the Grignard reagents and this is the acetylene minus bullet. So this minus will directly go and react with, okay, so this minus will directly reacts and upper Cl will be out. So like this way 2 Cl, so that means I can say so this C minus, in the place of C minus there is a CH2 CHO, and C triple bond C CH2 CHO. Now see, if I add H3O plus, in this case this H3O plus, if I do, so it will form a, it will gets reduced and it will form CH2OH HOH CH double bond CH HOH and CH2OH. See, there is a meso, if you see there is a meso compounds is there, so that means meso compounds we know always, if it is in CH or something, any group, there is a HOH, HOH group, CHO group. So if it is passed through sigma plane, that is called that means that molecule is a meso molecule. So after reduce, P is meso, it's mentioned P is meso. Meso means, so there is a HOH is the right side, HOH right side, if I pass plane, so it will a meso compound. So this is the correct answer. So you check the answer, HOH is same side and CH2OH is above below, so that means this is the correct answer. Meso compounds you need to find out like this only. After that meso compounds in diperoxides, calcium carbonate, osmium tetroxides. Yes, okay, this one B is this one, compound is S means meso compound means this one, and after that S compound is done, and if I do osmium tetroxides, so osmium tetroxides, KOH diperoxide OH minus calcium carbonate, so this will form, and meso compound if I do this S compound osmium tetroxide, so in this case Q compound it will form CH2OH, so 18 compound is this one, C2 and C5 should have opposite. see, this is the alcohol, and if I give a concentrated H2SO4, so it will give this kind of carbocation. Here is the carbocation. This carbocation will shift to gain more stable carbocation. Now see, in this case, this carbocation, and from any side it will form a and it will form a double bond from this sides. So it will form a double bond like this. Now see, if you add NBS, it will give, there is a Br, and if I add KCN in that, KCN it will attached, so it will form a Cn, and Cn, there is a, if I add H3O plus, now if I add H3O plus, Cn will become a COOH, but will I get the same product? No. So this is the not correct answer. So if you add NBS, this one, after that if I give H plus, so it will form a this thing, COOH, and there is a and this kind of complex. Now see, so answer will be C. So this is the correct mechanism. This is the final point. Okay. Total number of pi bonds. Total number of pi bonds. Okay. Last question is the total number of pi bonds in pyrene responsible for its aromatic behavior. So in this case, total number of pi bonds in pyrene, this is the pyrene structures and aromatic behavior. Now see, this is basically, this pi bonds is not participate in aromatic behavior. Now you count how many pi bonds? 1, 2, let's change the color. So total how many? 1, 2, 3, 4, 5, 6, 7. Total कितना? 7 number of pi bond. 7 number of pi bonds. So 7 pi bonds means how many electrons? 14 pi electrons. 14 pi electrons means 4n plus 2, if it is satisfied or not. Yes, it is satisfied because when n equals to 3. So this is the correct answer. Okay, this is the, these are the questions of JEE Advanced. Okay, we'll see in next class.